Hello and welcome to Studying with Chris, where I try my best to explain topics to help both you and me understand concepts. Today we'll be going over multiplying and dividing radicals. So, this is an example of a multiplying radicals equation. And you wouldn't really be asked to find the answer of it. Most of the time, I believe you'd just be asked to put it in its simplest form. So, in this case, basically the main rule is that when you're multiplying and dividing radicals, only the coefficients will multiply the coefficients and only the radicands will multiply by the radicands. So what I mean by this, if you have x root y times a root b, you just simply get x times a root y times b. This is only assuming both the indexes are equal. Okay, now using this, let's try to simplify this. So most of the time, you just use distributive property. So this value would be multiplied to these two values, and this value would be multiplied to these two values as well. So let's take a look at this. So you have 2 root 3 times 6. That would simply be 12 root 3. You have 2 root 3 times 3 root 7. You would simply just have 6 root 21. You now have 5 root 2 times 6. That's just 30 root 2. And you have 5 root 2 times 3 root 7. And that would be 15 root 14. Now before we move on, do you have any factors of our radicands that can be simplified? No, we don't. So this is essentially our equation. If we really wanted to, we could factor out a GCF, but it's not a fraction, so we don't necessarily need to. But if we really wanted to, we could say this is divisible by 3 and 4. This is divisible by 3 and 2. This is divisible by 3 and 10. This is divisible by 3 and 5, such that we could say this is 3 times 4 root 3 plus 2 root 21 plus 10 root 2 plus 5 root 14. You could hypothetically write it in this way, but you generally might not need to. Now, this is multiplying radicals, and that's essentially the gist of it, is just to use distributive property when you need to. Now, let's look at dividing radicals. So before we go into dividing radicals, let's look at a quick example. So you might have seen an equation like this, where you're asked to simplify this. Now, this is known as a difference of squares, where it follows the property that a squared minus b squared equals to a plus b times a minus b, where the value here of a squared would be a perfect square and b squared would also be a perfect square. So in this case, b squared is 81, which in fact is a perfect square, and a squared is 4x squared, which is a perfect square as well. So in this case, the values would just be the roots of it added together and subtracted together. So 4x squared minus 81 would simply just be 2x plus 9 multiplied by 2x minus 9. Now, these two terms here, these are known as conjugates, where a plus b is a conjugate of a minus b, and a minus b is a conjugate of a plus b. Similarly, 2x plus 9 is a conjugate of 2x minus 9, and 2x minus 9 is a conjugate of 2x plus 9. Now, how does this tie into division with radicals? Well, Often in division of radicals, you'll have to do something known as rationalizing the denominator. So essentially, that means, say you have, let's see, 2 plus root 2 over 3 minus root 3. So often in radicals, you can't really have a radical in the denominator. So you'd often try to what we call rationalizing the denominator. So you bring all the radicals into the numerator and leave the denominator as a whole number. So in this case, you'd have to use equivalent fractions, which is just multiplying it by a fraction of 1 in order to bring the radicals into the numerator. Most of the time, when you rationalize the denominator, you just use the conjugate of the denominator. So in this case, 3 minus root 3, the conjugate of this would just be 3 plus root 3. And then you do the same up here, since we can't change the value of the fraction, since this as a whole is equal to 1, so we'd just be multiplying it by 1 and we don't change the value. Now, using the conjugate just means we can kind of use the theory of difference of squares in order to find our denominator quickly. Hypothetically, you could multiply by a different radical in order to get a whole number, but that just requires more effort than using the conjugate. So in this case, our conjugate is 3 minus root 3 times by 3 plus root 3. And since we know that that would just equal to a squared minus b squared, we can just very simply write this as it's equal to 9 minus 3, and that would just be equal to 6. So now that our denominator is cleared, we now have all of our radicals in the numerator. So just like multiplying radicals, we just need to use distributive property. So here we might need to extend this. We have 2 times 3, which is just 6. We have 2 times root 3, which is just 2 root 3. We have root 2 times 3, which is 3 root 2. And we have root 2 times root 3, which is just root 6. Now, we need to check to see if we have any like terms. We do not, since our radicands are all different and our coefficients wouldn't match regardless. So we can simply write this as 6 plus 2 root 3 plus 3 root 2 plus root 6 over 6. Now, you may be wondering why we can't cancel out 6's. If you're not, that's okay, but if you are, just try to think, why couldn't we? Well, that's because you're using division of addition. So by that, I mean, if you have a plus b over c, this is equal to a over c plus b over c. However, it is not equal to a over c plus b. So in this case, we couldn't say 6 over 6 would cancel out since all of these are connected by addition. So since we can't simplify it further, this would just be our final answer. Now that we have that, we're just going to try some practice problems. Okay, so these are some practice problems. If you'd like to pause the video and try them on your own, otherwise we'll be going over it shortly. Alright, so let's get into it. So we'll first multiply this by its conjugate since we know this is a binomial. So we'll multiply this by 3 plus root 3, and since we can't change the value, we have to keep this multiplied term as 1, so we'll do 3 plus root 3. Now, using our difference of squares, we can just simplify this as 9 minus 3, which is equal to 6. Now, let's do distributive property on the top. So we have 3 times 3, so this is 9. We have 3 times root 3, which is 3 root 3. We have root 6 times 3, which is 3 root 6. We have root 6 times root 3, which is root 18. Now, we can simplify some of this. So we have 9 plus 3 root 3 plus 3 root 6. And we can simplify this to 3 root 2, since 18 has factors of 9 and 2, and the 9 can be taken out. So we have 3 root 2 over 6. Now, would this be our final answer? The answer is no, because we have a common factor of 3 in all of these terms. So if we want to make it our simplest factor, we take out 3 from the numerator and take out 3 from the denominator, so we make it our lowest possible equivalent fraction. So essentially, we divide the entire top row by 3 and make it a factor of 3. So we have 3 times 3 plus root 3 plus root 6 plus root 2 over 3 times 2. And these would cancel off. So we just have a final answer of 3 plus root 3 plus root 6 plus root 2 over 2. And we can't simplify it further, so this is our final answer. Awesome. Now let's look at our second problem. So we have 4 root 2 minus 3 root 10 over 7 root 3 plus 2 root 10. Now, this is going to be a pretty big one, but it shouldn't be that difficult. So once again, we can see we have a binomial at the bottom, so we just simplify it by multiplying by its conjugate over as a fraction of 1. So what would that look like? We have 7 root 3, and we do minus 2 root 10 over 7 root 3 minus 2 root 10. Once again, we know this is a difference of squares, so we can just simplify it by saying it's 7 root 3 squared minus 2 root 10 squared, and that would be 49 times 3, so we just use our calculator if we need help with that. So we have 147 subtracted by 4 times 10, 40, which means our denominator will be over 107. Now, let's work on our top slowly now. So, once again, we'll just do a distributive property. So, 4 root 2 times 7 root 3, that would be 28 root 6. Negative 3 root 10 times 7 root 3, this would be minus 21 root 30. Negative 2 root 10 times 4 root 2, this would be minus 8 root 20. And negative 3 root 10 times negative 2 root 10 would be 6 root 100, which we can simplify to 6 times 10, which we can just do plus 60. Now, we do have some radicals that can be simplified. So we have this 20, which the 4 can be brought out. So we'll simplify this all, saying 28 root 6, which cannot be simplified, minus 2130 also cannot be simplified. However, we can bring this 4 times 5, so we can bring the 2 out. So we'll have minus 16 root 5 plus 60 over 107. Now, before we say this is our final answer, let's quickly check over to see if there are any common factors. And there are not. So this itself just be our final answer. That will be all for today. If you have any questions, please let me know. Otherwise, thank you for studying with me.